Just as you're filling up the seats at the back here, there's actually still quite a few free seats in the front. And since we're expecting to take questions from the floor, I'd really like to invite you to come forward. The reserved signs that were there earlier in the piece, they've all gone. So there's a better view from here, I think anyway. And moreover, I can see your faces, which is a bit difficult if you're sitting in the back because I'm looking into the light spots here. And so beyond about row 4 or 5, it's getting a bit difficult.
That's already done, so it's a majority vote.
Okay, so we'll maybe wait another couple of minutes till people have all arrived, and then we'll get going. Okay, so if you'd like to come in and get seated, there's still quite a few seats over there, and they're not taken. So if you'd like to be close to the front, it'll be easier for questions from the floor in a mo. And also, if you're sort of sitting in the back and you're finding we're hard to recognize at the front, then do please come forward. There's still quite a few seats up front. Okay. Good afternoon, everybody. Did everyone have a good lunch? Okay, super. So welcome to this afternoon's panel discussion on satellite connectivity in the Pacific. My name is Ulrich Speidel, and I've come here from the University of Auckland in New Zealand, where I do a little bit of research on the behavior of TCP over satellite links, and specifically with the question of what we can do in order to improve the lot of people who have to get their internet via satellite in places like the Pacific Islands. And this afternoon, I'm really, really delighted to be joined by 3 experts in their own respective fields. So on my immediate left here is Haroon Rashid from Amstrat VSAT, and we'll do a little bit of an introduction, in a mo. John Brewer, who you'll probably remember from this morning, is our esteemed keynote speaker, who's really taken care of most of my introduction already, so I'll just whisk through this fairly quickly. And Steffen Holz over here, who's working as a consultant for Speedcast, who are one of the big satellite providers in this part of the Pacific and beyond. So what are we wanting to look at? Well, basically, satellite connectivity in the Pacific, specifically with respect to internet. So when I got asked to chair the session, I just thought to myself, okay, What am I going to talk about in the introduction here? And so the first thing I looked at is, well, what sort of satellites do we actually have available? And the classical sort of internet satellite is your geostationary satellite, and there's about 370 of them currently in service. When I say approximately, what I mean by that is that they're constantly being replenished, and there are constantly some that fail, and you always risk that if you're coming up with an exact number that it's out of date about 5 minutes later. Now, important thing is also to look at where they are. A lot of them happen to be across Europe and the United States Atlantic, which is where they sort of traditionally tend to be because of the early dominance of NASA and ESA. So if you look at anything that's sort of between about 90 degrees east and 90 degrees west, the sort of Wake Pacific region, then slightly under half of those would be sitting over the Pacific. Now, not all of them provide internet. So there's your weather satellites, your military, quite a few TV satellites. And again, of those, and as we heard this morning, that do provide internet services, not all of them provide them to just anyone. So your typical satellite in a geostationary orbit will have a couple of dozen transponders. Numbers do vary up and down a little bit, but the more transponders you want to provide, generally the heavier you have to make your satellite, the bigger the rocket you need to bring it up there, and the more it'll cost, but the more you can spread the capacity of the satellite across the region and across users. So when I'm talking about a transponder can carry anything. It can carry TV, it can carry radio, it can carry specific telemetry services, etc., or it could carry an internet signal. So your typical launch masses for those things are between about 1.5 tons and to just over 6 tons. Much heavier than that becomes difficult because you need fairly large rockets for that. But generally, the heavier your satellite is, the more solar panels it can carry, and the bigger the antennas it can carry. So it becomes easier to provide a significant number of spots and project significant transmit power into those spots. If you're going out of the geostationary orbits, we have the O3b medium Earth orbit satellites. O3b is now part of SES, as we heard this morning. They currently have 16 satellites, but they're intending to upgrade. And we were actually hoping to have somebody from SES here today. Unfortunately, they couldn't make it. But hopefully between the four of us, we'll be able to answer some questions in that respect. And I'm also mentioning the Iridium low-Earth orbit satellites here because in principle they can do very low bit rate internet, although you'd find it very, very hard to use them in the present version for anything more than email. So this is essentially the hardware that we kind of have up there available to project the connectivity. And looking at the Pacific, this is what a geostationary satellite sees. Depending on which longitude they're at, you can sort of turn this a little bit to the left and to the right. And as you can see, we see mostly nothing, or mostly water. And moreover, most of the land that you see here already has cable. So John was talking about this quite extensively this morning. So basically, those who haven't got cable, or many of those who haven't got cable, are likely to have cable in the next few years. So the problem is that at the moment, or for the foreseeable future, next 2-3 years, at least, there'll be quite a few also that will not be anywhere near, getting cable, and where a cable either isn't on the horizon or it's not economical. And it's not likely to be economical for some while. And they're going to be stuck with satellites for the internet for a while. And so if you look at the list of names here, and it's by no means complete, there's still quite a few. And so the big worry that I have is that what we're really getting to here is that we're getting a bit of a digital divide happening, because everywhere else where we have fiber, As John mentioned this morning, we can put more fancy terminal equipment at either end of the fiber, and then hopefully, unless they've put funny electrical repeaters into the cable, we can generally increase its capacity over its lifetime, and then what we end up with is basically a resource that grows with demand. But the problem that we're dealing with here is that we're dealing with a satellite resource for the rest of the world, or for the rest of the Pacific world, that is. And that satellite resource isn't really growing the way that fiber is growing in terms of both a large number of new cables, or for that matter, the capacity on satellites is pretty much constant. And moreover, my own research has led me to the conclusion that a lot of the satellite capacity that's currently being deployed to islands isn't actually used particularly efficiently. So the problem that we're getting is that on the one hand, we're getting a shrinking number of people who need satellites, so therefore the cost for the service needs to be spread between them. The next problem that we're getting is that for these people, the pressure to sort of compete with everybody else in terms of internet access and sort of keep standards up, so to speak, is becoming harder and harder, and we're doing this within the confines of a constrained resource. So this is really what's brought us to today. And in that big picture, there are lots of individual little questions. For example, our expensive bandwidth creates bottlenecks. That influences TCP performance together with the latency that we see in particular on geostationary satellites, right? Those of you who've been to previous IPNIC conferences and who've been to the workshops and who are going to be here for the rest of the week, obviously, you'll know what a big topic IP version 6 is. Now, I don't know anyone who's doing IPv6 over satellite at the moment in a sort of Pacific Island ISP scenario. So what's going to happen when everybody else has changed over to IPv6? Also, when you go to island groups in the Pacific, you often find that when two islands are trying to talk to each other, especially if they're within the same island group, very often what happens is that there's not just one satellite link involved, but two. So why? Then when you have off-island teleport positioning, often we'll find questions like, we come to an island and the people on the island mightn't even know where the other side of their satellite link ends up. And so depending on who they primarily talk to, so for example, people in Tonga, for all I understand, tend to send lots of emails to and from New Zealand. So when they were still on satellite, that came down on the other side of the Pacific on Vancouver Island. And so we had all the additional latency of the Southern Cross cable there. My personal pet peeve, satellite link input queues. It's one of the things that the satellite provider will typically dimension for people. For some odd reason, they're still being run at a capacity of something that's more or less equivalent to the bandwidth delay product of the link itself. Router queues, at least competently adjusted router queues, haven't been dimensioned like that on the internet for the best part of a decade. We use much smaller queue capacities these days. It's one of those things that the satellite community hasn't necessarily adopted yet, and there's reasons for maybe why they should be adopting this. Also, when you go out into the field, you often find WAN accelerators, performance-enhancing proxies, and other strange devices being deployed out there. They can be freeware, they can be fairly expensive boxes, and nobody really seems to know how much of an advantage they actually bring, right? Then there seems to be also a new paradigm that's sort of creeping up. So the classic model is if you live on a Pacific island, you'll have one or two ISPs there, depending on how large your island is and what the politics on the island is like. And so typically the satellite connection will be a pipe from the outside world to the ISP, and the ISP then takes care of the local network. But now we get businesses like Pacific basically floating the idea of direct-to-site internet. So in other words, you don't go to your local ISP anymore if you're on the island to buy your capacity. You go straight. You go straight to somebody like Pacific and say, hey, can I have a small dish and a contract with you, right? Then when I go out into the islands, I often hear people and local ISPs and so on complain that, we're still on this contract with X, Y, Z, and it's going to run for another 5, 6, 8 years. We wish we could get out of it because there'd be better stuff around now. So all of these are questions that I'm just sort of throwing towards you that maybe, I'd like you to think about whether we can, come up with a sort of local or personalized flavor of it. And of course, there's probably a bunch of topics I haven't mentioned here and that we'd like to sort of, hear from you about. And so before I sort of turn things, to the floor here, what I'd just quickly like to do is I'd quickly like my fellow panelists to introduce themselves. And I'd like to start with Haroon here, and then I'll start it off with a question, and then hopefully we can get a few more questions from the floor after that.
Thank you. My name is Haroon Rashid. We own a small satellite company called Mstret VSAT. Funnily enough, we're actually using Pacific network. So at the moment, we are on KU band, and we have a satellite connect to the a Russian satellite link. So that's why we have a temporary KU band on it. Next year, hopefully, we will start with a KA band, which we tend to supply most of the rural areas in PNG. So our focus more or less is supplying the rural areas in PNG that has no cable. So we are the only link for them to actually have internet. So that's what we do. We put hopefully a very small dish when it comes to the KU band. Right now, the dish we use is a 1.2 meter dish, which is smaller than the C band dish that normally for the Pacific region, which reduces at least the cost a bit. We all know how expensive satellite network is. So our aim is to actually reduce the cost and trying to see how we can put it down. And maybe when you guys ask us more questions, we'll be able to respond to that.
So in addition to submarine cables, I quite like radio and wireless, and I've spent most of the last 15 years throwing noughts and ones through the air and trying to catch them. I built a microwave service provider in New Zealand and sold that a few years ago, and now I'm doing conferences. It's fun. I love satellite today because it's like microwave in the sky, moving microwave in the sky, occasionally laser beams too. The new satellites coming today, especially in the KA band, as Haroon mentioned, have the ability to do huge amounts of bandwidth. We're talking about 2 orders of magnitude more bandwidth in a couple of years than some of these islands have ever had via satellite. The downside, which I'm sure we'll talk about soon, is that with these higher frequencies, you have real problems with rain fade, and I experienced these in Auckland with microwave links, and my microwave links at lower frequencies would be fine, and my microwave links at higher and higher frequencies would be less fine in the weather. So I have lots of questions when it comes to how KA band is going to work, but that's enough for now. Stephen?
Yeah, thanks, Jonathan. Look, my name is Stefan Holst. I started in the satellite industry about 20 years ago. We created a company. I'm a co-founder of the company called Pactel International, which was founded in 2003. We were focusing on the satellite industry in the Pacific, and until about 2013, I would say we were very successful. We had a massive market share in the Pacific, and we were subsequently we sold to Speedcast, who is now a global VSAT provider, one of the biggest VSAT providers in the world. And since 2013, I am working for Speedcast as a consultant for the Pacific region. So as far as my technical expertise is concerned, I've built satellite dishes from 60 centimeters to 16 meters. So we've done a lot of inclined orbit tracking, and we obviously follow the industry very closely. We believe that we know what's happening in the future, and we are still very excited. Even if people say satellite might be a thing of the past, I actually think absolutely contrary. And I'm not saying this as a sales pitch, I'm saying this as a private citizen. Satellite has a massive future. Especially in regards in areas where fiber rollout is very slow, because it's really a great thing to pull a submarine cable to an island, but then you have to distribute the capacity to the people. And when you can't do that for years, satellite could do that within a month or two. And there's really exciting opportunities out there in the future.
Right, thank you. So I promised to start it off with a question of my own, and it's one that really goes to all three of our panelists. And I'd like you to imagine for a moment that you were an internet service provider on a small Pacific island with a few thousand people on it, and your satellite contract came up for renewal. And my question is, given what you've learned about satellite connectivity, what would you now consider in picking your next provider, and what would you consider being important questions that need to be asked of your new provider, but also how would you approach it in terms of your local infrastructure and adapting that?
Maybe I will consider the timeline, because contracts are very, very long when it comes to satellite providers. We're not talking about 1 or 2 years, we're talking about 5 to 8 years in contract. And then you find out that also there are a lot of development coming in with the new cables coming in, with a cheaper and cheaper rate coming in, and how do we compete in this new world where the cables are coming in. So if I'm considering anything else, I will also consider a clause where we can renegotiate some price, renegotiate the price of our contract if ever there is new technology coming in and into the market.
I would insist that my provider give me services from more than one satellite at once, because each of the types of satellite networks, low Earth, medium Earth, and geostationary orbit, have very different characteristics. They use different types of radio spectrum. They have different carrying capacities and different rain fade issues. So personally, I would take a low Earth orbit with a very low frequency L band and a geostationary with a very high frequency in Ka band. And I would combine the two to provide a good service to my end users.
Yeah, Ulrich, you asked what would I ask. Customers nowadays is price. They only want price. The cheap, I can't say the word cheap ass, they want cheap ass. And that is a bit of an issue because it becomes a commodity. Satellite bandwidth is now becoming a commodity. Everybody asks, okay, the megabit per second, how much is that? Is it $500, $300, $800? We are trying desperately to show the differences in service levels. For example, a C-band service we can guarantee, or anyone, I'm not saying Speedcast, but anyone can guarantee 99.98% availability, which is a really great availability. On KU band, you can't do that. And all 3B, you can't do that. So I think what's important is that the customers ask, if I was a customer, obviously I would not sign for 5 years. I know that other people do that, and I know that other operators force people to sign for 5 years, but that has technical reasons because they have to pay for a launch in a year or two. In general, what we do is we sign for a year. If somebody wants to sign for 3 years, hey, no problem. That's good. But given the price erosion over the last couple of years, and I'm going back a couple of, when I started in selling capacity, and that was about in 2005, the megabit price was at $8,000 per megabit. And I've got actually one customer here who paid that amount a couple of years ago, but that wasn't because we were making a lot of money. It's because the space segment was very expensive, and the ground segments and the modems and IP backbone was expensive. Nowadays, prices for the same sort of setup has dropped to sub $500 levels. So yes, you don't want to sign for 3 or 4 years because you don't know what's going to happen, especially with LEOs coming in low Earth orbit satellites in a couple of years, 1 or 2 years, that will change the picture dramatically, and there will be more or less price erosion and different quality of services provided by different operators. So yes, what Jonathan's saying was right. Get a package, get backup. If you're on KA, get a backup of C-band. Make sure that critical services can be routed over to C-band, which is geostationary mostly. That's important. But unfortunately, the question I get all the time is, what's your price?
Thank you. Now it's your turn. So I'd like to invite from here on questions from the floor. Do we have anyone who'd like to ask a question? Yes.
Hi there, Aaron Hughes, 6Connect. I think it was Jonathan that gave a presentation some time ago about like the future of what LEO and MEO might look like. I watched the presentation and I had this this vision in my head that the Earth would be evenly scattered with LEO satellites everywhere on the planet, and internet access could actually be ubiquitously reached at low latency, and maybe even things like routing decisions could be made in the sky where we could actually properly get shortest path. Is the architecture of the LEO future internet in the sky coming to some standard? Has there been more development other than, you know, some satellites that are available at reasonably low latency in the LEO space, or, you know, where is it at today? I sort of envisioned another internet around the planet, and I'm kind of wondering if there's been any real advancement in that space.
Steffen.
There are 4 or 5 different projects, as you might know, obviously for LEOs. Some of these projects are made with gateways, where, for example, there's a gateway sitting somewhere in Australia and serving around 2,000 or 3,000 kilometers in diameter around this gateway. And in the Pacific, that's not really useful, because obviously if you had something like a gateway in Fiji, you might get to Vanuatu, and I'm not even sure if you get to Tonga, and then there will be a lot of water. And these gateways are very expensive. There are other satellite systems, which means, I'll just explain that quickly. The satellite signal goes up from the user, goes to the satellite, and since the satellite is pretty low, it actually needs to go down in line of sight to a gateway. And that gateway is becoming the new ISP. In the Pacific Islands, that would be sometimes the operator, that would be the local, might be a monopoly telco, which is sort of counterproductive for these systems. In other parts of the world, it might work. In the Pacific, that might not well work. But we have other systems who are going up, which will actually talk satellite to satellite, which meaning laser communication from satellite to satellite. So the signal goes up from the end user to the satellite, and then will go from satellite to satellite to satellite, and then go down somewhere in an international gateway. There might be 1, 3, or 4, or 5 around the world, one in the US, one in Asia, one in Europe. And that obviously makes sense in areas where you don't necessarily want to install a gateway. Is there a standard? To my knowledge, no. Every system will have their own standard. So frequencies will have standards, and antennas are probably going to be compatible, but all the software on the modems, and most likely the modems, might not be compatible. So if you're thinking, oh, every system will actually cover the whole globe. I mean, some systems have up to 4,000 satellites which is going to fly around the globe, so you don't really need a second or backup system. But as far as I'm aware, there will be no standard, and it's the best man who will survive, or 2 out of the 5 will survive, and the 3 others will give up, because it costs a lot of money to launch these services.
I have a few things to add there. There were 7 approved by FCC for new low Earth orbit broadband networks, and I think there are a few more that are seeking approval. Since the applications of some players like OneWeb and SpaceX's Starlink and LeoSat, they've gone back to the FCC asking for an additional set of satellites, also at low Earth orbit, but a little bit higher, and for V-band spectrum, which is millimeter wave, to build an overlay of backhaul right above the lowest Earth orbit satellites. So you're going to see a lot of cross-linking between these networks and a lot of transit around the world. We have 2 problems in the Pacific. Number one problem is jurisdictional. You have countries who do not want broadband to land overseas. They want it to land in country so they can control access to it. I mean, can you imagine what happens when a prime minister says shut off the internet and it can't happen? Yeah, that's not going to work too well. Another problem is these low Earth orbit satellites. Yes, they are going to blanket the globe evenly. However, when they're over vast areas of ocean, they may shut themselves off to save power, because these things have a limited lifespan, and their lifespan oftentimes is tied to how much power they're using. And if they can save power by not being on all of the time or turning some of them off as they're in the middle of nowhere, then they might just do that. So we might not have quite the blanket of LEO here in the Pacific that we thought we would. So there are great things coming, but there are also a few caveats.
Just adding on to that, there's also the additional issue that, of course, if you wanted to have a LEO that was operational during its entire orbit, or fully operational during its entire orbit, then that's a matter of power consumption, and the power on a satellite, unless you want to give it a plutonium battery or something unsavory like that, is basically going to have to come from solar panels. And you've got to remember that when a satellite orbits the Earth, half of the time of that it's going to be in the dark, and so it's not going to be able to collect solar power. So that's another reason for why machines like that would go into low power / power save mode over a part of their orbit where they're needing to recharge. Right, so we've got, did this answer your question? So Jeff.
Hi, Jeff Houston, APNIC. I heard two use cases, and they seem vastly different. One is long haul, and geostationary is an obvious answer. LEOs that relay is a less obvious but equally viable answer, but it's basically the replacement to undersea cables or an alternative. Fine. The other use case I heard was local reticulation. This idea that within a country, within a regime, I use a satellite to get to places where I simply cannot do some kind of Earth-based communication. And I'm kind of wondering about the experience with Google's Loon. I think there was a Facebook kind of thing out there as well, which takes low Earth and goes even lower. I did hear presentations about the use of Loon in Puerto Rico when the local mobile tower infrastructure had all but destroyed. They're able to steer balloons over there and actually do femtocell technology just up there. To what extent do things like Loon and this increasing ability to be able to accurately position almost passive balloons above populations alter this picture? Because if all I want is handhelds to reach the base station, doesn't things like Loon really have an answer? What's the experience in New Zealand, and what are your comments about things like very low Earth, high altitude systems?
Yes, John, would you like to answer that?
I do remember when Loon launched in New Zealand, and I have friends who were involved with it. Loon has run into a few problems. Problem number one is that floating balloons that you don't have a lot of control over where they go, this is a problem for aviation. And I'm sure the reason Loon never got off the ground in Indonesia was because of a failure to reach appropriate agreements with their aviation department. In the beginning, Loon was using ISM spectrum, so they were using modified Wi-Fi radio equipment and the radio frequencies that we use for Wi-Fi, and they've stopped. They've moved to using LTE. Once you're up in the air and you've got an antenna facing down, you see a tremendous amount of interference. So, yes, you get a huge broadcast area, but you also get an equally huge area of this is noise interfering with the signal that I'm trying to get. And most noise isn't pointed up, but as we can see, these Wi-Fi antennas, they're all omnidirectional. All of the Wi-Fi antennas in here are omnidirectional. If these were outside, their signal would be going straight up into the air. So they've moved to LTE spectrum, but that means they need to partner with a cell phone carrier. And that's hard work because cell phone carriers are conservative. And then with their technology, they found that, well, it doesn't really go all that fast. I mean, they made a big deal of Puerto Rico, but they were talking about how many gigabytes of traffic they served. And a tower in Puerto Rico before it had been destroyed was probably doing that many gigabytes in a few hours. And then they were down to, oh, we've done this many gigabytes over 30 days. So you're looking at a capacity that's probably 3 orders of magnitude less than the network it was replacing. So non-deterministic position messes with aviation, problems with radio spectrum. There are other high altitude platforms. There's a company that's doing tethered blimps, company in Boston doing tethered blimps. That's a great idea because it's going to stay in the same place, and you can use more directional antennas. They're printing the antennas on the outside of the blimp, which is quite big. Of course, there are the drones, but Aquila has been shut down, and Google has shut down their Solera, and I don't know of anyone really doing drones for telecommunications except Airbus. It seems that Facebook has rolled some of their IP into something with Airbus. So that's my update. Stefan?
Yeah, I think the idea really sounded really sexy some years ago. I'm not sure that anything has really evolved beyond a proof of concept. And I even heard that the Airbus, I mean, I'm not saying this officially, but I'm just heard that the Airbus drone project has been shut down because it just costs a lot of money to keep the drone up there. Because you're talking aviation, and bottom line is if that thing falls off the sky, you have responsibility, liability issues, and all these kinds of things. So with the price of bandwidth going down and terrestrial coverage getting better and better, competing with LTE or 5G at one stage, I'm not sure this is going to work, and I think that actually everything which has been launched has never got above proof of concept.
I do have a friend in PNG who is actually trying to test the same concept, but one is not getting permission from NICTA, the licensing authority, because of the issue with aviation. He needs license permit also from the aviation. And then secondly, we're not sure how is he going to control the balloon up there, and wirelessly controlled. And we know sometimes it fails. And for it to actually work will be, you have to have a very good technical capability to actually do it. I don't think it will sustain in the long run, because what happens if it fails and then it comes down? It's just, yeah. Yeah, so I don't think it will kick off. I don't think so. But again, he really wants to give it a go.
What price point would make it attractive? Because after all, you're busy bemoaning the fact that all this stuff costs like crazy. And if I could put something up for, let's say, what was the benchmark in LA for wire? 15 cents a meg. If I could put balloons up for that price, would you buy?
Of course, but...
Right.
Yeah, but...
So in some ways, you're bemoaning the situation because your expectations is that it will cost the earth.
No.
But if it's really cheap, would you be a customer?
Well, I'll wait with the danger of it. The danger is more than the cost itself. It will be cheap, but if it's going to cost a lot of lives, then I don't want to pay for it. I don't know.
If you can guarantee the price point and it's your problem up there, why wouldn't I buy it?
Yeah.
This is, I suppose, part of what I'm sort of looking at and trying to understand, that I hear a whole bunch of no. Much the same as
no. The only thing
ago.
I said is that what I've seen and the proof of concepts have been around, haven't been commercially viable. That's all I said. So, but I'm not saying, look, most of the customers don't care where the megabit comes from. If it comes, it's about latency, quality, and price, If it comes out of the wall socket, if it comes from the sky, it doesn't matter. So I don't think that the customers would really care. I think if you can provide a service like that out of the sky on a reliable basis at a price point which is interesting, I can't see any reason why anyone wouldn't buy it.
What's the price point of latency with geostationary then? Because if latency is important, and we all know geostationary is about as bad as you can get, what's the discount you need to do if I'm offering a service on geostationary versus something else?
That is a very good question. I can't answer that.
I feel like it's not a good question because you need to have multiple methods of delivery. Geostationary bandwidth is incredibly good for cache fill. Think about this. What is the internet now but 20% direct end-to-end and 80% cache? So if you can do your cache fill over the geostationary, who cares about the half-second latency as long as you have your interactive going over a faster method, even if that interactive costs 5 times as much?
But why did Amazon then do a cable rather than just simply buy cable capacity to fill its caches?
I have a feeling Amazon will take anything they can get. And I have a feeling that when the space lasers come, Amazon's going to be all over that.
I think there's the additional issue also of frequency reuse. If you compare a balloon or drone-based solution, then you're basically, at most a few kilometers up, and so the horizon of what your drone-based cell or whatever you want to call it, your drone-based receiver or transmitter can see will typically be, within a very, very small footprint. So the upshot of that is that you can basically reuse the frequency resource in other areas that are a bit further down the road. You can't easily do this when you have a satellite which has a much, much larger footprint, or then you get into sort of tricks like beamforming and stuff like that, but that only ever buys you that much at the end of the day. So really I see those, from my perspective, as being solutions for probably different application projects. So I would probably put the balloons, especially the sort of tethered balloon solutions or the drone solutions, as being something that might work reasonably well in an area that's sparsely populated, but that's where the population is so concentrated in particular spots that are sort of all within a few dozen to a few hundred kilometers away from each other. And the Pacific in many respects goes a little bit beyond that reach. So the idea is that, for example, if I wanted to project connectivity into a place like, for example, Niue or into the Cook Islands, then they're so far away from the next piece of land that even a drone or a balloon or a single balloon would not be able to handle this simply because of the horizon that it can see. When I then go and look at a potential solution of chaining several balloons and chaining several drones, we're getting into the area of reliability again. They're all in the atmosphere, so I'm getting weather effects, rain fade on the uplink, on the downlink, and then depending on how high up there are, if I get a big cumulonimbus cloud in between, then again that might just shut that link down. So at that point it gets quite complex again, and there's also the question of how do I actually keep a balloon or a drone reliably in position in a weather affected area over ocean. Over land where I can tether it down, it's easy. Over ocean that's 5,000 meters deep, it's not so easy. So at that point we're sort of probably getting very much into the experimental area again, and that's what also worries me a little bit along those lines, where I think that satellite's probably still at this point the better solution. Question for me a little bit is also, and it's already been mentioned, the question around latency. And one of the problems that I see in my work around latency is that we have a transport protocol on the internet called TCP that basically is reliant on feedback from a receiver. And that feedback from the receiver is incredibly useful if it arrives quickly, because that allows us to control congestion on a bottleneck, and whatever we're going to put there, whether it be a satellite or a drone or whatever, unless we've got very low demand in the location we're trying to service, we're going to be having a bottleneck, because anything that we can connect either end in terms of Ethernet or fiber is going to be having higher capacity. So we're going to have a bottleneck. If we've got a bottleneck with high latency, what basically happens is TCP finds it really, really hard to hit the sweet spot and make proper use of that bottleneck. And so I'm always very hopeful when I hear people talking about medium Earth orbit or low Earth orbit, because it gets at least part of that problem solved, in the sense that it brings the latency down, and it brings it down to far more comfortable levels. And for example, the simulation work that we've done actually shows that for the same amount of bandwidth, if you're projecting it via a medium Earth orbit satellite, you can get vastly more round trips done, and you can complete vastly more TCP flows from the same number of client sockets in the same amount of time than you can complete via geostationary satellite. But having that said, of course, what we have at the moment are geostationary satellites. What we have are a single monopoly provider of medium Earth orbit satellites, and we've got the promise of the low Earth orbit satellites on the horizon, but I'm not sure that we actually got at this point a business model, let alone dried down technical standards on how we're going to run that. So my question would probably be a little bit: how far do you think is a workable worldwide LEO system that's going to get you a reliability of 99.999%? How far do you think that's going to be away?
Well, we had the example with O3b a couple of years back. When O3b started, it was supposed to be the solution to all our problems. And it is, I would say it's now getting there, but the early beginnings were not easy at all. Between satellite issues and link budget issues and antenna tracking issues, we were actually selling O3b and we were selling a C-band backup at the same time. That has evolved a lot recently, because you have now geographical redundancy, meaning you have an O3b station somewhere, I can't remember the figure, but I think it was 30 kilometers away from the other station, and that actually solves most of your weather-related issues. And the C-band backup is gradually going away. So what we hear in the industry as far as LEO, because the question was about LEO, where are we? Well, I mean, officially we are from 2019, there will be the first test, 2021 will be operational. And there are a couple of, as Jonathan mentioned, up to 7 looking to build this issue, so it's a race. And some people are in this race not for the money, they're in it for making the world a better place. Like initially, Greg Weiler was with O3b. O3b stands for other 3 billion. It's the other 3 billion which were not connected at that stage. So I think it's going to happen. I think it's going to happen quicker than we think. However, there will obviously be teething problems initially, and the reliable 99.9%, we're probably 4 years away, I'd say, but that's really a rough guess.
Thank you. Just looking at the floor again, do we have further questions from the floor? Not yet. Okay, then I have another question.
I'd like to go on about the LEO. I don't think that we're going to see 5.9's reliability. I think we're going to see maybe 4.9's reliability, because networks like Starlink, SpaceX's Starlink, are intended to be direct-to-consumer broadband. And the way they've modeled it financially, they need to charge people about $60 a month US for service, and they can make their numbers. I've read their SEC filing about it, so they can make their numbers. However, people don't want large antennas on their houses. People want 60 millimeter or 60 centimeter or 90 centimeter antennas, as our friend from P&G knows. They don't want huge antennas on their homes, on their businesses, and so they're going to say, okay, I'm going to take a service that's going to stop a little bit in the rain in exchange for that. Of course, any service, nearly any service, is going to be close to 5.9's if you can put a 16-meter antenna on it. It just, it gets past the atmospheric problems. But I don't think on a large scale we're going to see super high reliability out of the LEO networks, because it's going to be good enough for the consumer nature of that broadband.
Obviously, I guess we're also talking about here how large a LEO network will be and how many satellites will be involved, because every additional satellite that's within view and within the view of, say, for example, an electronically steerable antenna is going to provide redundancy. So this may well be something that'll grow over time, but may not be there from the word go. And again, if we've got multiple organizations sort of starting up with this that are competing with each other and that are eating into each other's markets, that may well also prevent any of them getting to the point of maturity in their network where they're going to be dominating all of the others to the point where they can provide that redundancy. So that is sort of one thing that I see. But I've actually got a question for you, Haroon. One of the things that sort of baffled me a little bit was when Pacific came up and said, hey, we want to be putting a high throughput satellite there. And I looked at this and said, well, okay, whatever you're going to call high throughput, and we're talking maybe somewhere in the gigabit per second here. Now, my understanding is that this is not simultaneous gigabit per second connectivity to each individual site, because the system simply won't have that capacity as such. It's a shared capacity, for all I understand. And then you're still looking at having geostationary latency there, and then you're still having all those problems that come with having a long latency bottleneck. What are you sort of planning for your business to do about this and to deal with these issues from your customers?
Well, the business model you're going to have is that you're not solving a latency issue, because the latency is definitely going to be there. However, for the rural community that we are focused on, that doesn't have internet, and now having a small dish that actually can give them internet so many times of the day, I think they will not care about the latency. Bigger companies that latency is an issue, these are not our focus market, because we will not be able to solve their issue on latency, because the latency is there, it's a shared capacity, but we can go up to a 1 gig.
Yeah. But so looking at this, perhaps flipping the table a little bit on this. One of the big things that latency causes in terms of problems is that when you're having large TCP transfers, the large round trip time basically causes the TCP congestion window to open very, very slowly. So as a result of that, large file transfers, downloads, software downloads, upgrades, and so on, they take an enormously long time. Now I know that the likes of Google and Amazon all have their little standards, things like BBR and so on the wings, in order to make it a little bit easier to deal with this sort of stuff. But ultimately, my question is, and this really also goes a bit to the community and also to those of you here who may be looking a little bit at protocol design or middle box design or this sort of thing, is what is it that we can do to mitigate the effects of that long latency to people that are basically reliant on geostationary satellite services that cannot avoid that latency?
Without a cable solution, for now, I think that's going to continue to be on. O3b is having a better go at it with the new satellites coming in. I think they will solve that problem a bit than our system, a Ka-band. Ka-band will not, I don't think they will be able to solve that issue on the latency. That has to be there. It's just the satellite is too far away.
Right. I think Stefan would like to say a word here.
I think we just have to differentiate between the business case. We have a business case, Pacific, and I can't speak for them, but I mean we had a very similar project some years back, the rural internet connectivity system in the Pacific, which was working on a geostationary and KU band. Well, prices were more expensive, so it was a good 10 years ago. But it addressed the areas where there was no connectivity or very slow connectivity, or ADSL had 200 kilobits of speed because it was too far away. So this is not a solution. Direct to home geostationary is not a solution in the long run to solve everyone's problems. If you can be on fiber, you should be on fiber if the price is right. But what I'm missing a little bit today is, I'm not trying to be Elon Musk here by all means, but let's dream a bit. Let's dream a bit of a system which is capable of worldwide coverage with speeds which is far quicker than what we get nowadays on most ADSL connections and on most fiber connections, which are artificially slowed down by the operators. Because today you can buy fiber and you still get only 10 megabits, but the fiber is actually capable of doing a gig. But the operator slows you down because otherwise he's not making any money. So I think what everybody has to look out, whatever the LEOs will do, they will disrupt the market. One thing is for sure, they're going to disrupt the market. They're going to get in with a $60, whatever the price point will be, but it will be a retail price point with capacities like 50 down, 10 or 15 up. That's the theory. And once electronical steerable antennas will be available at reasonable rates, well, the system will cost a couple of $100s. So I'm looking at several islands in the Pacific, and I think, but that applies in Asia Pacific everywhere, that you have areas which will have ADSL or slow whatever services for the foreseeable future. And in 2019, 2020, there might be a solution out there where a guy puts a pizza box on his roof and gets 50 megabits. And that's something which will change the business model of most ISPs. And that's something people have to consider and have to work with, and it's going to happen. It might not be super successful from day one, but it's going to happen. The technology is theoretically capable of, and people are backing it who want it to happen. So it's going to happen. And people who can spend $2 or $3 billion on it, and if it doesn't make any money, that's not a problem initially as well.
Right. No, I don't. In fact, the only thing I'd contradict is that in New Zealand, they don't artificially slow down the speed of the fiber, and everybody still makes money.
That's because you live in Wellington. They do that in Auckland. I can assure you that because they do that for me. So.
There are several different models going on with the low Earth orbit satellite. You have the direct-to-consumer model of SpaceX Starlink. You have the backhaul-only model, which is LeoSat. So LeoSat is going to provide backhaul for cellular towers. And even in New Zealand, we now have some new 4G cellular towers that are satellite backhauled, still with geostationary, but that will change. And then you have the partner model, which is what OneWeb is going to pursue, where you're going to buy your service through your cellular operator. And your cellular operator's radio spectrum is going to be used between the OneWeb terminal and your device. So OneWeb is going to use the KU band to link from the satellite down to a terminal, and then from the terminal it'll be most likely LTE in the last 10 to a few hundred meters for your connection, and that can only happen when OneWeb is partnered with a cell phone company. So three very different business models, and it doesn't exactly leave a lot of room for small wireless operators or small satellite operators, but let's have one speak and see. What do you think?
No, you're touching on some of the business model that MStrat is trying to do on the 4G network. One of the things that we want to do is actually bring the internet down into one site and use 4G technology to actually push it out to the community. That's a cheaper way to actually getting multiple of dish into the homes. But talking about that, you need a spectrum license, which at the moment in PNG, for example, there's none available. All the 4G license being taken by all the major telecom companies, and so we are negotiating so that can be released, so that actually small company like us can able to pay for a spectrum license to actually able to have a cheaper way to distribute internet. It would still have the latency, but people will. It's actually, if you look at it, it's cost plus service. So when you're able to provide somebody with an internet for just 2 or 3 seconds difference in receiving the internet, as long as it's a lower cost, they will go for it because they want actually the service that they don't even have. And in PNG, what we experience is even the cable is so unreliable that people are actually going for the satellite dish, which has more reliability than, believe it or not, than the cable network. So for the maybe the next 4 or 5 years, VSAT technology will still be needed in PNG. That's for sure. And even when the new link comes in, the rural areas will not be the beneficiary. It will be only in the capital. So there will still be a need for a satellite network. And the cheapest satellite network will be the KU or the KA band. Definitely the KA band next year will be the cheapest one. The C band, the setup cost, the dish is very expensive. So the way you lower the cost for consumer, I think for now that's the way the route we're taking is more or less the cost reduction that we're giving. Right now, actually, to be honest with you, our price plan on a KU band is the same as the cable in PNG at the moment. So it gives it more competitiveness, even though the latency is there.
So what do people get on your price plan compared to what they get on cable?
They get the same speed because okay. So for example, we go as far as one dish we can push up to 40 Mbps in one 1.2 meter dish. So give or take on different price plan, they determine what speed they want to have. And we can do that either a shared plan or we can do that with a dedicated link. So with the dedicated link, definitely is a bigger companies, but we tend to have a shared plan of 4:1. And we don't go above 4:1. I know that some do 10:1 share, which is totally really slow. So we keep it 4:1 contention.
Right, so next year when the Pacific satellite launches, what change do you expect that to make to the plans you'll be able to offer to your customers?
Our price plan will go down 40% more, lower than what we're doing now. Now we're using KU band, which is slightly more expensive than what the price will be on the KA band next year. So it will be a cheaper price plan coming next year, mid next year, hopefully.
I have a question now. When you move from KU band to KA band, are you going to need more electricity to run the modems? And if so, how is that going to impact the cost of the solar panels and batteries associated with the satellite?
Funnily, the KA band modem has lesser electricity use than the KU band. Yeah, so a 450 watts panel can power your dish. So it's very, very cost effective when it comes into play. And so people can able, in the village, they can able to have a very small panel that actually power the modem. Even the modem I'm using right now, the GLAB modem I'm using, is about 250 watts. That's including modem and the access points all combined. So we're using very, very low power to power it.
Right, so I notice we've been discussing among ourselves here, but I was really hoping that we get a few more questions from the floor. Does anyone, maybe somebody anyone here from the Pacific that might want to ask a question that they always wanted to ask? Yes, please.
Hello, I'm Jean-Luc Fudina from MLS, Micrologic System. I don't have a question, but just a few remarks, because I hear a lot about latency. Everyone is focusing on latency, but I'm before 2008, New Caledonia was with satellite connection, and latency never been a problem as long as your links are not congested. This is completely different things. The only times when the latency is a problem is for the real-time game. You know, everyone knows your reactor, and too bad your opponent already killed you. But except this case, everything else works just fine if you can manage the bandwidth. And just to contradict Stefan, managing the bandwidth is not limiting the customer, is to help the customer to have better internet. And just to finish, as a small ISP, when we had the submarine cable in 2008, of course, we have a lot of bandwidth we want to share to our customer, because we have twice the bandwidth capacity to serve our customers. But in fact, we have side effects. We opened the bandwidth for everybody, and we have a lot of complaints because the very last miles links were congested, because the subscribers, the end users, don't know how to manage their bandwidth. So their lines were congested and they have latency, you know. So, I mean, for satellite business, as long as your links are not congested or managed correctly, latency is your very, very least problem, I think. My opinion.
Yeah. I would actually beg to disagree a little bit with this. For two reasons. The one thing is that the round trip time on your satellite link actually determines how quickly the congestion window of a TCP connection will open, because basically your congestion window is the number of packets that your TCP sender will be willing to leave to the channel unchecked. And if you're downloading something from overseas and you're having a satellite connection in between, then you're basically having a 500 milliseconds plus round trip time.
Yeah, but...
And now, the thing is, if you're, for example, just web browsing, then most of your connections will be done within the number of packets that fit within a single congestion window. So the congestion window will never need to open. So for things like these, it doesn't matter too much. The moment you start downloading large stuff, like, you know, for example, software distributions from overseas, you know, large cap files for Windows updates, and, you know, heaven knows what. It's that point when you're not streaming, but you're actually downloading with TCP. And it could even be something as simple as an email attachment. That gets noticeably slower when you're on a satellite connection, and it gets noticeably slower, even if that connection is not fully used. For example, I know that at a time when I visited a certain island group that's an O3B customer in the Pacific, I had a look at their link utilization statistics, and it basically showed that at the best of times they were getting up to about 55% of link capacity that was actually used. But it was very, very noticeable when I was trying to, for example, download email attachments. Getting emails where you were only looking at a few kilobytes per header, no problem. That came down in no time. But the moment you try to get an attachment that was a few megabytes in size, that required an opening of a multiple round trip times with an opening of the congestion window, that was the point where it started to slow down quite considerably. And that's something that's easy to recreate in the lab, and it's something that has to be that way with current TCP stacks. I absolutely grant that when you're looking at things like streaming, where you're dealing with UDP or UDP-like protocols, when you're looking at stuff like Skype, for example, where there's no significant amount of feedback involved, you're not dealing with problems like these. Then latency is not an issue. But the moment you're looking at TCP-based downloads or large TCP-based transfers, this is when latency hits.
Okay, to be short. For all you have mentioned, Stefan could maybe confirm there's a lot of equipment, maybe costly equipment, like TCP acceleration. I don't remember how much boxes cost. We have a few solutions for it. But just keep in mind, the ideal network is every link are the same, and of course, the longer the link is, the more latency you will have any result, of course. But here, you're in totally different situation because every link are different size, capacity, and before, what I say is just before focusing on latency, which for what you have many solutions, maybe costly solution, but you have solutions. Except for really real-time application, but most of the time it's gaming. Your first problem is to manage your bandwidth, because bandwidth is more expensive and you have to manage the bandwidth. For everything else, you have solution. I do believe it's more important to give internet to population, even if you have to wait 1 second of latency, rather than no internet at all.
Okay.
It's just my thinking.
I understand the importance of connectivity, and I do know about those middle boxes, which are usually either WAN accelerators or the performance enhancing proxies of sorts.
Yes, we do have some, and it's working.
The thing is, they are a solution, but they're not a solution to the problem of latency. The problem of latency at the end of the day is between the sender and the receiver. What they can help with is things like packet loss, right? For example, through things like network memory, making sure that packets that get lost don't need to be retransmitted all the way, right? Or things like parity packets, for example, that might be available. But the actual end-to-end latency between the TCP sender and the TCP receiver, that's what governs the opening of the window. And there is no middle box you can put in the middle that's going to solve that problem.
In my experience, packet loss is more of an misaligned equipment, and we all know satellite, with the distance we have a certain latency. We all know about it, but we can compensate as long as we know. It's just like you have to travel somewhere. This is a 6 hour long. This is a 2 hour long. So you can when the equipment want to send packets to a longer link. Okay. Let's send more traffic, so this will compensate the packet loss, TCP, etc. We don't need to go too much technical here.
If you know that this is a transfer you got to run, and you have control over both sides of your connection, then yes, you can do this.
That's what the equipment are doing.
But the simple thing is that in a consumer internet environment where you're downloading from any willy-nilly server on the planet, you have no control over their TCP stack. And so therefore optimizing their TCP stack from your end is impossible. And that's one of the big things. And I have yet to come to a place in the islands that's not fiber connected, that doesn't have problems with latency.
Yeah, but these equipment are to be put at each end of the satellite network, not on all the network,
Yeah.
So we had the experience before 2008 in New Caledonia with a satellite only.
Yeah. Look, we installed over the years, and we still install accelerators on trunks, what you call a satellite trunk, meaning from A to B, from overseas to an ISP in an island. And these boxes work quite well. They give you efficiencies, they give you increased throughput. For an academic like you can measure they're fixing a problem and making it look nice. Obviously, if you measure it from end to end, you still get, obviously, latency. The only solution is to move the satellite closer to the Earth or the Earth closer to the satellite. And that is not practical. But I think what Jean-Luc is saying is that it's equally important to manage your bandwidth. I mean, silly story. I was on a Skype call with my wife yesterday. She's in Australia. I have a ping running on the side because I can stop talking when sometimes something happens to my computer. My ping goes to 3 seconds, and I'm on fiber. So this is really important that people understand there's not only latencies, there's quality of bandwidth management, prioritization, and making sure, and that actually starts with a home router. You know, a lot of people say my internet service provider is rubbish, you know. Why? Because somebody at home sends a 20 megabyte video file or something, you know, and then everybody comes screaming, and since I'm the IT professional in the house, everybody says, your internet is shit, daddy. You're in the business, yours should be better. Well, it's, sorry, can't fix it. But this is, I think, Jean-Luc's point, is that it's equally important to actually manage the bandwidth, the quality of the bandwidth, the protocols, prioritization. Latency is not everything. If you're on a on a good tuned satellite geostationary link, you get a good experience. It's not going to be fiber, I'm not going to lie to you, but it's going to be very good, and in most cases better than what people get nowadays at their home.
So let me ask a follow-up question to this one. And it's also a bit of a follow-up question to, I guess, the first question that I asked, is if you were to dimension a geostationary link to an ISP that had, for argument's sake, 1,000 customers, how big would you make the link for a good experience? And that's the question. I know it's a loaded one in some respects, but...
Well, in my case, it depends entirely on the economic status of the place you're delivering to, because the peak hour utilization in some wealthy markets is more than 1 megabit per second. So in the evenings, 8 to 10 p.m., people are streaming their Netflix, and the average use per customer is 1.5 megabits per second. And in other markets where there is no streaming or infrastructure for that, and the costs are lower, the peak hour utilization may be in the tens of kilobits per second. And so if you're selling satellite into a wealthy market that expects these sorts of things, then you need to provision for that. And if you're selling it into a market where people haven't had internet before, or are paying $2 or $5 a month for their connection, maybe they're sharing it amongst their village and they're paying a few dollars into the pool for this, and there's no expectation of having streaming media and television and so on, then you provision it for much lower.
Stefan?
Yeah, the answer is very simple. It doesn't. The question doesn't come up. It's really about economics. We had a country which most of the countries who actually moved from fiber, they double their bandwidth requirements on day one. So New Caledonia was 300 megabits on satellite, went to 600 megabits within 48 hours, and now they're up to 20 gigs. But that's, when did we get the cable? In 28? I think 10 years ago. So in 10 years, moved from 300 megabits to 20 gigs. But that's streaming, that's because people didn't bother with YouTube before, at least the ones which were not on a good ISP, and nowadays they do bother because that's actually how they consume. For example, our generation is sit-back TV. We're watching, Canal Satellite or Netflix or whatever. Sorry, Netflix, not Netflix, but any type of TV service which is proposed by a geostationary DTH service. And nowadays, I mean, you look at our kids, they don't even connect the TV to the wall socket anymore. They don't care. They just want it as a big screen for their computer. So they connect the HDMI cable from their computer to the TV, and that's it. If I ask my kids who are 20 years old what's on Friday night on TV, they have no idea. No idea. They have never watched regular TV. And that's the generation which is going to pay our internet bills. They will, which means there's a big change nowadays, and it has happened years ago, and it will continue to happen. And I would say it's the end of traditional DTH television. It's the end of traditional TV stations. It's all what I want immediately, just in time. So that's just a thing I needed to get off my mind.
Right, yes. Okay. Do we have any further questions from the floor? Perhaps. This is your chance. Anyone from the islands, perhaps, who might be willing to comment, get a question off their chest. Okay, well then I'll have another question. Now, I was at Apricot in Auckland a couple of years ago, and there was somebody there from Akamai, I believe, who basically said, well, we're happy to peer with anyone in terms of putting local caching in, provided they have a secondary backup link. And it seemed to me at the time that, hey, really having local caching servers in Pacific Islands that maybe hang off a single satellite link, where there might be some backfill capacity at night or something like this, that might be a pretty good idea. And so I know that, of course, ever since there have been a few sort of open content delivery network initiatives that have been popping up here and there. And so my question is a little bit, at those of you who are in the satellite business, on the links that you look after or that you run, do you see a significant amount of spare capacity that could be used for that sort of backfill at off times?
For our service, there definitely spare capacity on in the evenings. During the day, it's full because our customers they use it a lot during the day, but at nighttime they don't in the office. So I transfer those capacity at night to homes, and I use it for TV. I actually use I don't watch TV anymore. I just use my box, my IPTV, and it works well. So there is a lot of spare capacity at certain times that you can use for certain things if you manage the bandwidth well and how you do the transfer.
In the old days, I think that's what we did on satellite, which means that we slowed all the caching services down and make them work in the middle of the night, because obviously you have this curve in the morning, 4 or 5 o'clock, people get up, it comes up, it drops off about at lunch and comes back up, and then at 11 o'clock at night it drops down, and then we use spare capacity, which was sometimes 30 or 40% of the link. Nowadays, when you have a submarine cable and the submarine cable is paid for, and on the other end you pay a couple of dollars for backbone, it doesn't matter anymore. So you just redimension the link to just work all the time. But I mean, what you heard from this guy from Akamai was probably just some years ago, a guy from the US who's used to have being super connected saying, oh, you need a redundant link. I mean, I know of plenty of islands who have caching, whether it's Netflix, Akamai, or Google, who don't have redundant links. And there's a minimum capacity requirement. I think it was 2 gigs or something for Akamai. And people just do it and it works. So I think the question has since resolved of having a redundant link for these caches, because it just makes so much more sense even on a single link. I mean, if you have submarine cable and you don't have a redundant link and you have no satellite backup, you have a problem anyway. It's not the Akamai cache that's going to solve an issue.
Yeah, maybe quickly. I think at that time I still used to work for Akamai.
It was you then?
I don't think so. I mean, we definitely at that time did deploy plenty of caches that only had a single uplink, and I mean they still add a lot of benefit while they work, right? I mean, if the uplink is down and that's the only link to the island, then there's no internet anyway. So I mean, it doesn't matter whether the cache is there or not. So I think, to your question about cache fill, I work for Facebook now. I still do caching. There's 2 kinds of caches, really, right? So there is stuff like, to a large extent, Akamai's or our equipment as well. That's very much real time, right? You cannot cache fill that off peak, because what you will cache fill off peak will not be what's relevant by the time it is peak again, right? So anything that is very user-driven content, off-peak cache fill doesn't work. But there is scenarios, well, Netflix being the prime example for that you can absolutely fill off-peak, where you have a known library of content that you know people will watch tomorrow. This is awesome. You can fill that in the middle of the night with spare bandwidth. But for a lot of the caches that are deployed in the islands, that will not work because they are user-generated content. That's more or less real-time fill. So I think this is two separate scenarios you can address there. And for the scenario for fixed library content, yeah, that's great. That works really well.
Right, thank you. Okay, so I've got about 5 minutes left of our session time. Do we have any further questions from the floor? Discussion, contributions, bits and pieces? Then if there's nothing, I'd like to just touch on another topic, and that's the regulatory side of things, which has been popping up a few times around the place. Now, I know this because John actually came up with this, earlier in the piece when we were preparing this, and he said, well, what if a particular, ISP, gets told by the government to, for argument's sake, and I hate to say this, turn Facebook off, right? Then how easy is this to do via satellite? And I think you might want to make that question more precise, perhaps, John? Of course, it came from you in the first place. So,
well, in an up and down satellite system, especially the ones that we still have through the Pacific, where the capital city may have a submarine cable and the outlying islands do not, and you're using geostationary capacity to go from an Earth station in the city up and then down to the remote islands. How easy is it to turn off the internet, which happened in Bangladesh when I was there last month? Very easy. Actually, it was just all of the mobile network's data, but yes, it was all turned off. In the case where you are an ISP and you're selling say Speedcast's service, does Speedcast sell into PNG with bandwidth that terminates in Australia?
Yes.
Yeah, okay. So then what do? Okay, you as the ISP, yes, you can get it all turned off at once, but then once we start having things like SpaceX where it's direct to consumer, are they just going to shut it off? Yeah, good luck with that. Regulatory is very hard, though. You'll look at this problem, and India has considered this problem, and so India is very tight with their satellite utilization, and if you turn up at the airport in India with an Iridium phone, they'll take it from you. They don't allow you to use satellite phones in India that aren't approved by the government because they want control and the ability to intercept communications on everyone's phone calls. There are a lot of governments like that, and faced with global connectivity, they are worried.
Yeah, obviously, I mean, as a company, we abide by the regulator's decisions. So, for example, if we sell to an ISP, the ISP is responsible in the legal agreement to abide by local laws. And if he doesn't, and we are made aware of it, we probably have, it hasn't happened, but we probably have an obligation to shape it for him, let's say it that way. So, but I think, this is actually a debate which is just, sort of the last grasp of a regulator where he thinks that he can control the internet. I think that's, in a couple of years, that will be finished because technology will be overtaking. And to stop internet in a country which has several in and out routes and which is a democracy, I think that's pretty hard. And the regulators probably have to get used to it. I mean, that's just a personal opinion.
Right. Which brings me to perhaps the last question on the list. Where do you see the role of IP version 6 in the satellite sector in the coming years?
Personally, I see V6 being used by OneWeb and OneWeb's partners in the connectivity between the satellite modems and the end terminals. Mobile data and LTE is best done with V6 now. That could be the biggest use of V6 and the biggest use of satellite that we see in the near future.
A couple of years ago, there was a panic about V4, IPv4. We need to get all the address space we could because it's going to run out. It's going to be the end of the world. Hasn't run out today. There will be a slow transition driven by technologies, and that's going to happen in satellite as well. So today it's not used, mostly not used. I personally haven't, I think we have some traffic shapers who try to identify, but most of the modems are actually not even capable of transmitting it.
Arun, do you know anything about the plans that Pacific have for use of IPv6?
I think we're only using 4 at the moment. I don't know what the plans yet for 6, but it's 4.
Right.
That was short.
That was a short and sweet answer. So looking at my watch here, we've reached the end of our session. I guess we probably have time for one more quick question if somebody's keen. Otherwise,
Well, on behalf of the programme committee, I want to say thank you very much for organising the panel session.
Well, thank you very much for inviting me and helping me with organising. Thank you. And yeah, I'd like to thank my three fellow panelists, in particular Haroon, who's had to come on board at very, very short notice because we were one panelist short. I think it's been really worth having all three of you on the panel, and it's been a really interesting discussion for me at least, and I hope that the rest of you may be able to join me in thanking my three fellow panelists here as well. Thank you. And now I believe there's coffee outside, is that correct? Okay, thank you.